The number of roots that a polynomial have, or solutions, or zeros, there's lots of different ways to say that, a polynomial has is the same as its degree. Now remember that degree is the highest exponent in a polynomial. So for example, this first example, x cubed minus 16x squared plus 4 will have 3 roots because the highest exponent is 3. The next example will have 4 roots because the highest exponent is 4. Now this number includes both real and imaginary roots, so just because it says you're going to have 4 roots doesn't mean you'll be able to see all 4 on the calculator if you graphed it. Now to solve a polynomial, here's kind of a flow chart of what you need to do. The first thing you always need to do is take out a greatest common factor if you can. Then you try to factor. So see if it's a special type of factoring like a difference of squares or a sum or difference of cubes, grouping, diamond problem. If it factors and you can set everything equal to 0, you're done. If not, then you can maybe use the quadratic formula, or you could try the rational root theorem, synthetic division. Those are all things that, in this little bubble here, these are all things we're going to talk about in subsequent lessons. This first example is a difference of cubes. There is no greatest common factor to take out. So the first thing I'm going to do is factor it as a difference of cubes. So my a would be the cube root of x cubed. B is the cube root of 27. And now I'm going to factor it using the formula. So remember, I have 2 terms and then 3 terms. Same sign, opposite sign, always positive. And now I'm just going to plug in my a's and b's. So x minus 3, x squared, 3x, and then 3 squared, which is 9. Now this whole thing still equals 0. Now I have 2 sets of parentheses. I'm going to set each one equal to 0. So I'm going to do x minus 3 equals 0. This one's pretty easy to solve. Add 3 to both sides. X equals positive 3. So I have one of my answers. Oh, and one thing I wanted to mention that I didn't yet. Whatever the degree is, which is 3, that's how many answers we should get. So I have one of my 3 answers so far. Now I'm going to take this one and set it equal to 0. This one is going to be a little bit more work. Way back when we first started talking about factoring, I said that if you use the formula for the sum or difference of cubes, that trinomial will never be factorable. That means we can't do a diamond because we'll never find 2 numbers that multiply to 9 and add to 3. So we have to use quadratic formula. So I'm going to identify a, b, and c, which are 1, 3, and 9. And then I'm going to plug them into the quadratic formula. So I have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So now I have to do some simplifying. The numbers under the radical are going to give me negative 27. So I'm going to write this again up here. Negative 3 plus or minus the square root of negative 27, and that's over 2. Now, negative 27 has a couple things going on. First of all, I can do a factor tree. It also has a negative, so I know that when I take out any pairs, I'm going to also take out the letter I. 27 is 9 and 3, and then 9 is 3 and 3. So I have a pair of 3's and a leftover 3. So I have negative 3 plus or minus. Outside the square root, I'm going to be taking out the number 3 and the letter I, and then inside the square root, I have this leftover 3. And then everything is over 2. Now I have to check my outside numbers, but none of them are divisible by the same thing. So negative 3, 3, and 2, all 3 of those things cannot be reduced by the same number, so my answer is complete. My next example, remember the first thing you want to look for is a greatest common factor, and I noticed that all 3 terms have an x. So the first thing I'm going to do is take out an x, and now all of my exponents are going to go down by 1. Alright, so now I have 2 things being multiplied that equal 0, so I can set each one of them equal to 0. This one's going to be really easy because if I set x equal to 0, it's already solved, so that's one of my 3 answers. And now the thing in the parentheses is going to be a little bit more work. You have 2 options here. This one actually will factor. I actually think, though, it's better to just use the quadratic formula, because then you don't have to worry about when it factors and when it doesn't. So if you can look at this and see that it factors and it's easy for you, that's fantastic. If not, I would just use quadratic formula, which is how I'm going to show you here. A is 2, B is 5, C is negative 25. So now I'm just going to plug things into the formula. Negative b plus or minus the square root of b squared minus 4 times a times c, oops, 25. And then that's over 2 times a. I'm going to go up here. So I have negative 5 plus or minus the square root. And when you do all of this, those numbers under the radical, you end up with 65 as your number under the radical. Sorry, not 65, 225. And then that's all over 4. Now 225 is a perfect square. So the square root of 225 comes out to be exactly 15. So when I rewrite this, I'm going to write negative 5 plus or minus 15, no radical anymore, because now I've taken the square root already, over 4. When this happens, when you are left with no radical and no imaginaries, what we're going to do is split this up into two separate answers, one using the plus and one using the minus. So I'm going to have negative 5 plus 15 over 4 and negative 5 minus 15 over 4. So again, you only split this up if you have no radicals and no i's. And now what I'm going to do is simplify these fractions. So negative 5 plus 15 is 10 over 4, which can reduce to 5 over 2. So that's one of my answers. And then negative 5 minus 15 is negative 20 over 4, which comes out to be negative 5. So here are my three answers. I have x equals 0, x equals 5 over 2, and x equals negative 5. So I have three answers, which matches the degree of my polynomial. All right, this problem, first thing I want to do is check for a greatest common factor. It does not have one. So the next thing I'm going to do is identify that it is a grouping problem. So that means I need parentheses around the first two and last two. And now I'm going to be doing greatest common factor. So out of the first group, I can take out 2x squared, and I would have 4x plus 1 left over. From the second group, I can take out a positive 5, and I would have 4x plus 1 left over again. And now to put it into my final two parentheses, I would have 4x plus 1 and 2x squared plus 5. So now I'm going to take each of these parentheses and set them equal to 0. So I have 4x plus 1 equals 0. Subtract 1 from both sides. So I would have 4x equals negative 1, and then I'm going to divide by 4. So I get x equals negative 1/4. So there is one of my answers. Now I need to take 2x squared plus 5 and solve it. This one's going to be a little more complicated because I have a square. That means it's going to give me two answers. So I'm going to choose to do this using quadratic formula. You could also use the shortcut that I showed you in the previous lesson. I actually think it's easier just to do quadratic formula because some messy things end up happening. So my A would be 2, B is 0, C is 5. So I would have 0. There's really no thing as negative 0, so I'm just going to leave it there. And then I would have 0 squared minus 4 times 2 times 5. And this is all over 2 times 2. All right, so I have 0 can kind of just disappear. I don't need it anymore. It's not going to change my answer if I leave it out. So what I end up here with is the square root of negative 40 over 4. Now the square root of negative 40, two things need to happen. Number one, we need to do a factor tree, and number two, we're going to bring out the letter I because I have a negative under a square root. So I'm going to break up 40 as 4 and 10. 4 is 2 and 2, 10 is 2 and 5. So I have a pair of 2's here. That means I'm going to bring a 2 to the outside along with the letter I. And then I have a 2 and a 5 left over. That gives me 10. And then everything's still over 4. Now I'm looking at the two numbers in front, the 2 and the 4. Those are both divisible by 2. So I'm dividing all outside numbers by 2. So it's going to turn into I square root 10 over 2. And that's my final answer. So this one in orange has 2 answers. The one in purple is my third answer, which accounts for all 3 answers if you look at my degree. All right, so the first thing we need to do is check for a greatest common factor, and I noticed that all 4 terms have an x, so I'm going to factor that out first. So I have 18x cubed minus 12x squared plus 15x minus 10. So right away I can get one answer. X equals 0. That's one of my 4 answers. Now I need to look at the thing that's left in the parentheses. That's going to give me my other 3 answers, and it happens to be a grouping problem. So I'm going to put parentheses here and here. Let's see, I can take out a 6x squared from the first group, and then I would have 3x minus 2 left over. From the second group I can factor out a 5, and I would have 3x minus 2 left over again. So I have 2 parentheses, 3x minus 2 and 6x squared plus 5. Now my first set of parentheses is not going to be too bad. I'm going to set this equal to 0. I'm going to add 2 to both sides. So I have 3x equals 2 and then divide by 3. X equals 2/3. So now I have 2 of my 4 answers. My other 2 are going to come from that second set of parentheses. And kind of like in the previous example, I'm going to show you using quadratic formula. Otherwise, some messy things are going to end up happening. So A is 6, B is 0, C is 5. And I'm actually going to start everything up here. So I have x equals, negative 0 is the same as 0, so I'm just going to write 0 plus or minus the square root of 0 squared minus 4 times 6 times 5. And then everything is over 2 times 6. If you simplify everything under the radical, and remember I'm dropping the 0 at the front because I don't need it anymore. All right, so if I take everything out of there, I end up getting, let's see, the square root of negative 120. And then everything's over 12. Now I need to do 2 things. I need to do a factor tree with 120, and I'm also going to be taking a negative out as an I. So I'm going to break down 120 as 12 and 10. 12 I'm going to do 3 and 4, and then 4 would be 2 and 2, and then 10 would be 5 and 2. So I have a pair of 2's right here. That's going to come out to the front along with the I, so it's going to be plus or minus 2I. And then under my radical I have 3 single numbers. I have 3, 5, and 2. If you multiply those all together, it gives you 30. And then everything is over 12. Now again, I'm looking at my 2 outside numbers, 2 and 12. They are both divisible by 2. And remember, I don't do anything with the number under the radical. That one is protected. So this is going to be plus or minus 1I, but I'm not writing the 1, square root 30, and then over 6. So now I have 4 answers. I have 2 answers here, 3 answers, 4 answers, which matches the degree of my original problem. This last one I would recommend doing as a difference of squares first. I think that's really your only option. Even though it's 2 terms, since it's not quadratic, we can't split it up and do that shortcut where we put 1 term on either side. So I'm going to do a difference of squares. My A is the square root of x to the 4th, which is x squared, and then B is the square root of 1. So I have x squared plus 1 and x squared minus 1. I'm actually going to deal with the second set of parentheses first. This is another difference of squares. So what I'm going to do is I'm going to factor this into x plus 1, x minus 1. So let me write this over here. I did A and B. A is the square root of x squared, B is the square root of 1, so it factors into x plus 1, x minus 1. And then each of these gets set equal to 0. So x plus 1 equals 0, so x equals negative 1, and x minus 1 equals 0. Add 1, so x equals positive 1. So here are 2 of my 4 answers. Now I'm going to deal with that last purple one. If I take that and I set it equal to 0, I can do that shortcut for this one. It's not going to be too bad. Usually you want to avoid the shortcut if x squared has a number in front of it. But since there's no number in front of x squared, I'm going to go ahead and put x squared on the left and -1 on the right. And now I'm going to take the square root of both sides. Remember, you need to put the plus minus, otherwise you're not going to get both of the answers that you need. So this ends up being x equals, now the square root of -1 is just the letter I. There's no other number that stays under the radical. So this is going to turn into being plus or minus I. And that is it. So there are my 4 answers. I have 2 answers here, 4 answers, which matches the original degree of my problem.